Intel RealSense LiDAR L515 is composed of three major technology blocks. The transmitter block is a laser diode and 2D MEMS mirror. The mirror directs the laser in a pattern that covers the entire field of view. The receiver block includes a single photodiode and amplifier. L515 uses a photodiode instead of a typical multi-pixel camera sensor, eliminating pixel crosstalk and reducing multipath artifacts. The depth block uses a custom ASIC to process 23 million depth points per second on the camera. This frees the host to focus on other tasks. LiDAR-based time-of-flight depth provides several advantages over flash-based time-of-flight. L515 depth resolution is determined by the scan speed and not by the size of a pixel array. L515 achieves a maximum resolution of 1024 by 768 real depth points per frame. A modulated laser signal collected with a single APD per pixel is more power efficient compared to flash-based solutions. The L500 technology supports field of view changes by repositioning the MEMS mirror. And finally, very short exposure times made possible with LiDAR virtually eliminate motion blur. L515 calculates depth per pixel and does not average depth over multiple pixels like other time-of-flight solutions. Comparing depth output of a flash-based time-of-flight camera with L515 LiDAR shows the advantage of L515 technology. The advantage of high resolution and minimum detectable object size is demonstrated in the bar test. You can clearly notice the 5 mm gap between the bars at 1 meter distance. Applications like picking and measuring will benefit from the high edge fidelity. The high depth density and high accuracy of L515 LiDAR make it an ideal solution for object scanning. The top left video was created using multiple L515 to scan a person quickly with extremely fine detail. L515 works equally as well scanning smaller objects. High accuracy and high edge fidelity also make L515 an excellent choice for measurement applications such as volumetric measurement of packages. Being able to clearly see edges and accurately measure products is extremely valuable in many markets.
Hello, I'm Massimiliano, MEMS designer at STMicroelectronics.
And I'm Gianluca, validation engineer at STMicroelectronics.
Today we're going to walk you through a short presentation and demonstration of ST's mirror device, which is inside the Intel RealSense L515 LiDAR depth camera that has been developed in collaboration between ST and Intel.
This device is an electromagnetic actuated biaxial MEMS mirror designed for LiDAR application. The MEMS works in raster scanning scheme. The mirror is driven in linear mode on the slow axis, reaching up to 60 Hz, and in resonant mode on the fast axis at 21 kHz. The reflective area of the scanning mirror is 1 mm in diameter and can reach a very large field of view of 62 degrees by 50 degrees while keeping the entire MEMS device compact, measuring only 3.53 mm by 2.8 mm. The mirror reflective area is gold coated, ensuring a reflectivity of over 95% in the near IR spectrum, and additionally a black cavity mitigates the straight lights. The mirror contains built-in PZR sensors that continuously sense the mirror movement and position deployed by using a set of resistors arranged in Wheaton's bridge configuration.
Let's now have a look at the mirror performances during the actuation. In our system setup, there is a red laser being reflected by the mirror surface. In this video, we are driving the device along its linear axis. In particular, we can see an example of projection at frequency lower than 1 Hz and slowly accelerated up to 60 Hz. We can also see in the corner the real mechanical movement of the slow axis mode. This is a measurement collected using a vibrometer. If instead we drive the mirror along its fast axis, at its resonance frequency, we can see the projected pattern at 21 kHz. Also in this case is visible in the corner the mechanical movement of the structure. Finally, we can drive the mirror to make a full 2D image if both axes are actuated together, obtaining a raster scan projection. Thank you very much for your attention.